This video shows some of the features available in the KappaWave ultrasonic machines. There are 5 models to choose from. It takes 4 seconds to boot and it's quite easy to calibrate. You can move the gates freely. Drag the vertical axis to change amplitude and drag the horizontal axis to change the range. Both gates can be used. For the primary gate, amplitude and beam path is given above, and for the secondary gate, it provides the information as B2 and A2 below. You can calibrate 25 millimeters to 6 meter in steel, and it can be saved easily. You can also measure low thicknesses such as 1 millimeter and 2 millimeter using echo to echo technique. There is an echo store function that is also provided. For example, the second echo from this is actually gated and then stored temporarily and then filled in. Later, this is taken off and then the probe is moved to another material where a similar thickness is expected. Now the probe is placed on the perspex insert on the V1 block. Now as you can see, the signal is slightly away from the stored echo, and also there is an amplitude difference which is indicated as E reference. There are 2 types of reject controls provided in the instrument, and this is the first one, which if you engage it will lower the amplitude. The second reject control works in a different way. If it is engaged, it will not affect the amplitude of the signal. Only the grass will be cut. There is a scientific calculator available. The instrument offers a good penetrative power. It comes with RF wave that may be used for testing of bondings. This indicates a good bond and this a lack of bond. The instrument offers a time-based AB scan. The machine offers a beam plot function. For example, as you scan on this block, the corner indications can be picked up. First the half beam path, then the full beam path. As you pull this further away, you can also pick up a 1.5 beam path. Now in the instrument, if you enter the angle and the thickness that is involved, it will plot 2 horizontal lines indicating the top and bottom of the material, and then the angular beam is also shown. So as you gate a signal, it will show you exactly where it is coming from, and this can be beneficial in locating a flaw easily in the field. And this is a 1.5 beam path. The instrument also offers a shaded beam path. this is a shaded area where that's actually a half beam path. From 0 to the where the shade begins is the first half beam path, and then the second half beam path as well. Machine offers an AWS function. It is being calibrated using a V1 block. The signal is maximized, and using the probe 0 control, it is moved to read beam path exactly as 100 millimeter. Once the calibration is complete, then the 1.5 mm sidewall hole may be picked up, maximized, and then set to about 40% in height. And then the AWS button is engaged. So right now it gives you A, B, C and D values. On the same V1 block, the bigger sized hole, 50 mm diameter hole, is been picked up. And that shows a large indication at a much higher amplitude. If it's outside the screen, then you may have to drop the amplitude a bit, re-maximize, and then look for the D value. Now in this case it shows somewhere close to a negative value, about 14 or 15, minus 15. Now this may be checked against the AWS code for acceptance. You can also generate a record out of this. You may engage the print function so that a static screenshot will be taken, and that will be saved in the instrument. There is a 14-point dynamic DAC available. Some backwall echoes are actually used in this case. Each point is taken, gate is moved on, and then recorded. And these are dynamic DAC. And it will change with respect to changes in amplitude or range. This may be saved, or if required it can also be converted into a static DAC. Click on the SDAC button once and a static DAC is enabled. Now with this, if you change amplitude or change range, the DAC will not change. It will remain as it is. There is a transfer correction method also. You can add whatever gain that is required, and it will be reflected in the total gain used. There is a TCG also provided. You record the first point and then move the gate to the second point, and you raise the amplitude to make it equivalent to the first one, and then click record. Do the same thing for all other indications. Once those points are recorded, then you may click on the TCG button once. So all these signals will be equalized. Now we can change gain if required. And to cancel this, click on TCG again and then go back to your DAC page and clear the signals off. There is a DGS curve function also provided. I'm using a 4 MHz normal beam probe on a flat bottom hole block. We will pick up a back wall echo out of this. Bring it to about 80% in amplitude. We will enter the frequency as 4 MHz. A and B is set to 0 and D is the diameter, which is set to 10 millimeter. And on the next page, the flat bottom hole size, desired size is entered as 3 millimeter. And then turn on the DGS function. And since this is against the back wall echo, click the DGBW button to complete. Now as you scan on the same block, you will also find a small indication coming up. This is the indication, but it's too small, so you raise the amplitude a bit to see the indication. Once the indication pops up, you gate the signal. That gives you the ERS of 1 millimeter. There are dedicated lock and unlock functions available. The machine also comes with BNC sockets. There is a VGA connection also available. It is supplied with protective cover, becomes easy to carry around the field. This shows a 45-degree angle beam probe used on an IOW block. The machine has a tilt stand as well, and it offers a video recording ability. Thank you for watching.